Is day 9 in geometry, and it is Tuesday, June 10th. And for your do now, I gave you 2 special right triangles. Your first right triangle, if you remember from the notes yesterday, does anybody know what is this type of right triangle called, ABC? Anybody know?
45, 45, 90.
Yeah,
90.
it's just a 45, 45, 90 triangle. We just name it by those angle measures. So I'm just going to write that above here. 45-45-90. And you'll notice on a 45, 45, 90 triangle, we have 2 sides that are the same length, X and X. And then we have one longer side that is X times radical 2. Okay, so these values never change, which may have been talked about in yesterday's video. So for number 1, it says that we're going to solve for the missing sides using this triangle ABC.
Taylor, I have a
Yeah, no, absolutely.
For some reason in my brain, when you posted that and said you weren't going to be here, I didn't come to class. I did
It's
take the
okay.
notes, but what is radical 2 mean? I didn't
Great
talk about that in the lesson.
Question. Great question. And I must have said it. Maybe I didn't. Did I not say that in the video? Radical. Okay, let's do a quick little side lesson then. Radical is a fancy word for square root. So let's write that on a little sticky note here. Radical.
There's no sticky notes on it.
There's no sticky notes on that table.
Here's some. I got some too.
Thank you, Amanda.
I tried to just say it.
Perfect. Yep. If anybody does not have sticky notes on their table, let me know. I've got quite a few extras up here. So this word radical, you can say radical to replace the bigger word square root. So I could say radical 2. That just means the square root of 2. So, Amanda, I appreciate you saying something because I bet everybody else was really confused.
Yeah, I was watching the lesson and I'm like, radical, I don't know what, where to plug it in. Okay, I got
Right.
it.
No, I appreciate you bringing it up because we haven't used that term in here yet, have we? We've used square roots, especially when we use the Pythagorean theorem. Yes.
I noticed that it looked like a square root, but there's also another button on the calculator that looks similar to the square root.
I bet I know what you're talking about. Let me find my calculator. Are you referring to
The one that's got like a chevron.
the one, let's see, right here?
Yeah.
Okay, so it looks like a square root, but with an X. So what that would be, hopefully we'll not be using that in this class, at least for now. But if you're curious, it's a different type of root. So a square root is what 2 numbers multiply to get this number under the square root. This could be, for example, a cube root. What number do I multiply 3 times to get the number under? It could be.
So it's just adding another dimension.
Yes, it is. It is. That's a good way to think of it. But don't worry about that. We don't need that today. So erase it unless you just find it interesting. Okay, so we're learning a new word today, radical. It just means square root. So if I have x radical 2, that just means whatever x is, I take that times the square root of 2. And let's see that in action in number 1. So for number 1, I have given you the length from point A to B. Said it's 3 inches. So one of the very first things I would recommend doing is looking at your picture and seeing what is from A to B? So on my picture, if I go from point A to point B, what red label do I have for that line? We have a 90-degree angle, we have a 45-degree angle. Now those are labeling the angles, but what is labeling the length this side? X. Good. So from A to B is X. So from A to B might not be a bad idea to put equals X over here to the side. My picture tells me that A to B is X, and it's been given to me in the problem that from A to B is 3 inches. So let's go back up to our picture and let's look at these other points. I don't know what the measure of B to C is. Yes, Erica.
If we know the shape of the triangle and we know A to B is 3 inches, then we can assume B to C is also 3 inches. And then from there, we can just use the
The Pythagorean theorem. Absolutely, we could do that. So Erica just pointed out a really good thing here. She said if we know that A to B is 3 inches, and we know that A to B is the same size as B to C, then B to C must also be 3 inches. Do we agree with that?
Yeah.
Well, that's good, because it's right. It's true. So how do we know that B to C is the same as A to B?
Because it's a 90-degree angle.
Not the 90-degree angle. Erica?
the other two angles are also 45 degrees.
Ooh, the other angles are also 45 degrees.
Both of them.
Now, there is one other way we can know this without even worrying about the angles. Rhonda?
Because they're both X.
Yes, they're both labeled X. So that means they're the same. So I know A to B is X. I know B to C is X. So I'm going to label that as well. Now, if X is 3 inches, then I can go to that next line, just like Erica said, X and BC is also 3 inches. We're just filling in the blanks here. Okay. Does everybody feel okay about getting 3 inches for B to C? Good. Okay, so now we need to look at A to C. What measurement is given for A to C? X radical 2. So I'm, once again, going to rewrite that measurement over here next to AC. I know that that is going to be X radical 2. Now, I know my X value, don't I? What is X? 3 inches. So if it helps to write this out to the side, I don't ever think that's a bad idea. In fact, I think it's a good idea. Let's just separately over here write X equals 3. So if I know that X equals 3, but I need to find X times radical 2, do any of you have an idea of how we might do that? Lisa?
Why don't we we have a symbol like
What's that symbol called? What's on your sticky note? What's it say?
radical.
Yes.
2.
Yes. So we're just going to plug in 3 for X and then multiply it by that radical 2. So here's what we're going to do. Over to the side, I'm solving for AC. Instead of X radical 2, X is 3. So we're going to write 3 radical 2. This is where we're solving. And what's really cool is even though this is a multiplication problem, if you type this in your calculator, you don't even have to use the multiplication symbol. We'll type it in just like this. Everybody, you're going to find the 3 on your calculator. Remember how to get the square root button? We're going to hit the blue second. And that x squared, there's where that square root is, or the radical. And then 2. And we'll hit enter. And you should get about 4.24. So everybody make sure that you can type that in and get the correct answer, because this is a bit of more of a calculator use heavy lesson. Because I don't expect any of you to know how to solve that in your head. So make sure you can get that answer on your calculator. We'll have 4.24 inches. Okay.
What did you say?
What did you get on your calculator?
I think I'm hitting the wrong thing up there on there.
Okay, here, I'll run through it again. So just look up here. We're typing in 3 square root of 2. So we're just going to start with the 3.
Mhm.
And then to get our square root, we're going to hit that second button, the blue one. And then the x squared. So does your screen look like mine so far?
Yep.
Perfect. And then we'll hit the 2.
Oh,
And enter.
I know what I did. I hit 3.
Ah, you hit 3. Yeah, that'll make a little difference. Did you get the 4.24?
Yep.
Good, good. Everybody got it? Yay. Okay, so we've solved number 1. We have both of the other missing sides. All right. Now, before we go on to number 2, do we have any questions about how we got any of these values? Okay. We want to try number 2? All right, let's do it. Now, number 2 is a little bit different because this time we're not given AB first or BC. We're given AC. So I always like to look back up at my picture. From A to C on my little diagram here, what value is given for the length from A to C? It is 20, yes, absolutely. Now, what if we don't know the number? What is the X value given to us? From A to C. X radical 2. Good. So I'm going to go down to the information given to me. I know from A to C is 20. And I also know from A to C is X radical 2. Okay, so we've got that so far. Now I have that biggest length, but I need to now solve for my 2 smaller sides. From A to B and from B to C, both of those values are equal because they're X. So if we solve for one, we can really have both of them. But now we have just 20 inches and it's X radical 2. What we need to do now is solve for X. Do any of you have an idea how we might do that?
Radical 2.
20, let's see.
Square root of 20, square root of 2.
Very, very, very close. Very close. So in the previous problem, we were able to take 3 and plug it in with the radical 2.
Oh, yeah, multiply.
But that was because 3 was X. You see that? Our X was 3. So I could replace X with 3. But is my X 20 here? It's not. So we don't know X. So we have to solve for X. I know that 20 inches is this length, and I know that this length is X radical 2. So those must be equal to each other, right? So what if I told you that we could solve for X by writing this? X radical 2 equals 20. So I've got this set up now. I don't know X, but I know that X radical 2 is 20.
Would you divide?
Yes, you would. Okay, so here's where I think a lot of us get a little bit confused, but it's not too bad if we just kind of simplify it and break it down. I don't know x. If I want to solve for x here, remember what's happening is I have x times radical 2. To get rid of times, we divide. So to get x by itself, we need to divide by radical 2, by the square root of 2 on both sides. See that? Divide by radical 2, divide by radical 2. Now, before we even type this into our calculators, what happens on this side of my equation?
Cancel out.
What part cancels?
The left side.
The left side,
The two twos.
the two twos, the radical
The radical
twos.
twos.
Yes, and what's left over here? X. We got x by itself. That was the goal. That was the goal. So x equals. And now on this side of my problem, I have 20 divided by radical 2.
14.
You got it? Okay, let's make sure we all know how to type this in properly. So whenever we're using division now, we're going to type that 20 first. So 20. And we're dividing. So divide. And same thing as when we multiply or we typed in the previous problem, we need to get our second square root and then 2. 20 divided by radical 2.
14.
Enter. 14.14. Before we move on, I want to make sure every person in this room can get that on their calculator. Give me a thumbs up when you got 14.14. Good. Good. Awesome.
So x is 14.
So x is 14.14. So how do we use this information? I know that this is x. How is this going to help us solve for my other missing sides? Erica.
The other side just are that.
The other sides just are that. Because why?
Because x is the length of those sides.
Perfect. If we look back at our picture, both of the missing sides are labeled as x. We just solved for x.
Yes.
So both of these are 14.14. Good. And if it helps, we can also label them as x before we fill that in. Sometimes it helps just to see that these are also x. And we got 14.14 inches. Yes.
So on the 45, 45, 90, the x's will always be equal to each other.
Yes. Always, always, always. That's a great thing to point out. So if you did not hear that, I want to repeat that. On a 45, 45, 90 triangle, these sides, the two short sides labeled x, will always be equal every single time. That will never change. Okay, so I will keep that displayed for just a moment. And before we move on to the next type of right triangle, make sure if you have any questions, this is a great time to ask. Yes.
So when it comes to triangles like 30, 60, 90,
Mhm.
do you always put the angle of the orders or the order of the angles from lowest to highest?
That is how I was always taught. So I'm going to say yes, but I'm sure it's also possible that maybe it could be labeled another way. I just don't want to tell you incorrectly. As far as I know, yes, that's how it's always labeled. But another way could exist. Okay. Yes, Rhonda.
Will it always be radical 2 on the longest side?
Yes.
Okay.
For 45, 45, 90 triangle, that will never change.
Okay.
Yes. So this picture that we have is a really good thing to keep in your notes, because on every 45, 45, 90 triangle, it will never change. It will always be like this. Okay. Can we move to number 3, or does anyone still need 1 and 2?
We'll be able to get a little bit more practice.
Yes, we're gonna do more practice today. We will. Let's go ahead and look at number 3 then. Move this over. So for numbers 3 and 4, we want to kind of switch gears a little because now we have different values for our side lengths. It's no longer x, x, and x radical 2. Now I have 3 different side lengths. The side that is the shortest, right across from my 30-degree angle, that's x. The side that is across from my 90-degree angle, that's my longest side, 2x. And then the side that is across from 60 degrees, my middle angle, that is x times radical 3. So on number 3, we have been given 1 side length from D to F, 12 inches. Now, one thing I will say for these triangles, the special right triangles, the very first thing you always want to try to do is solve for x. You want to get your x value because once you have x, you can plug that into all your sides and get all your lengths. So let's maybe write a little note up here that says solve for x first. So on number 3, just like I said, we have DF is 12 inches. What matches DF when we're talking about X values? What is the labeled, bless you, what is the labeled length from D to F in terms of X? 2X. Good. So I know DF is 12 and I know DF is 2x. So can I do this? Can I just write 12 inches equals 2x? Can I do that? What do we think? Yes or no?
I think, yeah.
You think yeah?
I don't know why, but I think it.
Does anybody feel that maybe they could tell me why I can do this? Why is this true? Lisa.
You're gonna divide both.
Ooh, I am going to divide both of them. That's right. But why do I know that 12 is equal to 2x?
It's the length from D to F.
It's the length from D to F. It's given to us right here in black and white. D to F is 12 inches. And our picture tells us from D to F is 2x. So if D to F is equal to 2 things, those 2 things are equal to each other. Okay? They're related in that way. So we already know that 12 inches is 2 times x. Now, Lisa, you said earlier something about dividing. What would we do next here?
You're gonna put 2 under the 12
Okay,
and 2 under the 2x.
perfect.
And you're gonna cross 2.
Okay, so we have 12 equals 2x. If we divide by 2, those 2's cancel. What's left right here? X. We solved for x. Okay, so x comes down equals, what's this value? 6. So x equals 6. And we could use this to solve the other sides. So I'm going to write up here just to have it x equals 6. So now that we have that x equals 6, let's look at our picture and see how can we use that to find the length of the other sides.
Well, if x equals 6, then that means E to F is 6.
Yes. If if x equals 6, then E to F must also equal 6 because E to F is x and x is 6. So we can go down here and find EF. I know that is x, and x is 6. So we have one of our sides. EF is 6 inches. So we have that. How am I going to solve for this last side, D to E? Lisa.
X. No, sorry. 6. Yeah, that word. What is it?
I don't know.
You know it. You know it.
Thank goodness.
It's on your sticky.
Radical.
Radical. Good.
Uh,
Okay, so you said 6 radical
3.
3. Okay, so we know x is 6. I know from D to E is x radical 3. So we're just going to take that x value, plug it in. D to E is x radical 3. So we're replacing the 6 radical 3. Now we just type this in. You got 10.39. See if I get the same thing. 6 radical 3. Yeah, I got the same thing. 10.39. I need to make sure everybody gets that as well. Make sure everyone knows how to type that in correctly. We should be getting 10.39 inches. Give me thumbs up when you got that on your calculator. Everybody get it? Everybody good? Good. Okay, awesome. Awesome. Any questions on number 3? Anything at all? We want to try number 4? Last one together, and then we're going to make sure that we can do this on our own. So I will give you some practice. So number 4, we're using the same 30, 60, 90 triangle, DEF. And this time, we've been given the length from D to E. It's 5 inches. Now, what is the first thing I said we need to solve for? X. So if I know that DE is 5 inches, how can I use that to solve for X? Erica.
5 divided by the square root of 3.
Yes. So how did you know to divide this by the square root of 3?
We just did that.
We just did that. Okay, let's see. How about let's just make sure everybody else has got it. I know you got it. You definitely got it. So DE is x radical 3. We all see that. We can make that connection. So why don't we start by setting those equal to each other, since we know that they are equal. X radical 3 is 5. So I'm going to write an equation. X radical 3 equals 5. And before we solve this, does anybody feel uncertain about why we set these equal to each other?
I don't quite understand why.
Okay, perfect. So let's just run through it again. DE is 5 inches. So I go up to my picture and I look for DE. DE is x radical 3. So if DE is, I'm going to write that, x radical 3, and DE is 5, then x radical 3 is 5. Yes, so we can kind of use some reasoning by looking back and saying, well, if DE is equal to this, and DE is also equal to that, then this is equal to that. Okay, so now, Erica, your step comes in. What did you do here?
And flip the equation around.
Flip the equation around.
What I did is 5, well, plugged it into the calculator. 5 divided by the square root of 3.
Perfect. So what would happen here is we would divide by the square root of 3 to get x by itself. Or 5 radical 3. So I am looking at this equation now. What happens to my radical 3's?
They disappear.
They disappear. They cancel. And what's left over on this side? X. We have X. I'll bring down my equal sign. And now we divide, just like Erica said, 5 divided by, 5 divided by 3. And we should get this 2.88675146.
2.89.
2.89. Yes, we could round that up. 2.89. And that is the value of X. 2.89. How do we round it up? So we have 2.886, and we wanted 2 decimal places. So we look at the 8, that's the second one, and then I'm looking at what's the number right next to 8. It's a 6. So if the number next to 8 is 5 or bigger, then 8 changes to 9. If it's 4 or smaller, then it stays at 8. But if you put 2.88, I would still count it, right? I'm not grading you on your rounding skills.
So E to F is 2.8.
Say that one more time.
E to F is 2.89.
How'd you know that?
It's X.
Because it's X. So Arthur just said, so E to F must be 2.89. Well, E to F is X. And X is 2.89. So E to F is 2.89 inches. Very good. So I have E to F, that was X. I'm gonna just label that. Now, how do I solve for the last side, DF?
Would it be, 2x equals 0.89 and then divide it?
Ooh, okay, so you said maybe do 2x equals 2.89? That's a really, really great idea. But I want to show you why that might not work, why that won't work. If x equals 2.89, can I say that 2x also equals 2.89?
Yeah, remember what you did for X.
This won't be the same thing. X is 2.89. So I can't say 2x is 2.89. But if I know what x is, and I know that from D to F, the length is 2 times x, can I solve for that length? Do I have enough information?
2 times 2.89.
Yes. So this is where, once we've solved for x, we don't have to solve for it again. Now we can use x. We're going to plug it in to solve. Instead of solving, we already solved. Now, yes, we'll do 2 times x, 2 times 2.89. So I'm just going to type that in there. 2 times 2.89. We should get, I got about 5.78. Everybody get that? 5.78. Look at that. A whole lot of work, you guys. So that is what we covered in that little video I posted on Classroom for you yesterday. And I know most of you already watched it, but sometimes it just doesn't quite click until you do it in person, and that's okay. So we are gonna kind of take a little more notes about this topic today, just to make sure we all feel good about it. And I don't mind spending a little extra time on this because this is actually the last thing in our triangle unit. So that means very soon we'll move on to our next. Okay. So I am gonna pause this for just a moment, leave it up if anyone needs to take more of these notes, and just be prepared. I'm gonna get out a notebook and we are gonna take a few notes together. All right, so I'm gonna move this to the side. If anybody needs to see it again, just let me know after class. And I'm gonna title my page for notes. So we are reviewing yesterday. And as we begin today, if everybody could take a moment just to make sure your phones are silenced, to make sure that it's not gonna ring or anything. Hear that a couple times, if that's okay. Geometry, Unit 2. And today is day 9. Oh, wow. I don't want to think about it because that means we only have 6 classes left. I'm gonna cry. This term is going really, really fast. And I just don't know how to feel about it. Some of you probably love it, but I'm getting a little sad about it. Okay, day 9 notes. And this is page 1. So again, yesterday you guys may have taken some good notes from the video I posted. We're gonna kind of redo those notes. I don't think there's ever anything wrong with repeating something and just getting it in your brain even more than you already did. So if you've already took notes on this, that's amazing. But we're gonna kind of do it again just to make sure it really sticks. So I am going to title our page once again as special right triangles. And today we're gonna, after I write this title, hang on, let me not get ahead of myself. Special right triangles. Today, my plan for you is to give you a bit of a step-by-step guide to follow. So when you do these problems on your own in the future, you can look back and say, okay, step 1, I need to do this. Step 2, I need to do this. Because there's a lot of steps in solving these. So I think it might be nice to have something to guide you along. And we're going to start one type of special triangle at a time. We'll start with our 45, 45, 90. And I would recommend you get a ruler because we're going to draw a picture. I'm going to start by writing 45 dash 45 90. And going to start this triangle with one line straight up and down, about 3 inches long. Can't see for 3, about 3 inches long. Then we want to create another line segment. And that next line segment should begin at the end of your first one. And it should be the exact same length as that first line you drew. So that first line I drew was 3 inches. My second line should also be 3 inches. If you chose a different measurement, that is okay. Just make sure that your picture matches. Because having an accurate picture in your notes will be really helpful later on. Once you have those 2 line segments that create a 90-degree angle, we're just going to connect the third side. This. Once we've got this drawn, we'll label the point at the top A. We will label the point at the right angle B. And the point on the bottom right side will be C. So whenever we talk about these angles, we can talk about them in terms of the letter that is labeling it. So for example, angle A is going to be the angle made up of these two lines. How many degrees is angle A? 45. Good. So we'll start by putting an arc on angle A and writing 45 degrees. What is the measure of angle B? 90. How can I indicate that? With a little square with a box. Like that. Okay, and what would the measure of angle C be?
45.
Also 45. So one arc to show that these are the same, and then a 45 degree there. Bless you. Now, we should be close to this point. We've got our angles labeled, so now let's do our side lengths. From A to B, you can look at your do now if you need to. What is the side length labeled as? X. And that will always be X. From B to C, what's that side labeled? Also X. Good.
They're both 45.
Yes, because they're both directly across from 45 degree angles, just like that. And if you don't see that, let me use like another color to show. Angle C is across from AB, like this. And that's 45. Angle A is across from BC. You see that relationship? That's how they're across from each other. Now, A to C, the longest side, is also, notice it's across from the biggest angle, the 90-degree angle. A to C, what is this side length measured as?
X radical 2.
X radical 2. Good. And again, that will never change. And over to the side, I'm going to have us write out these line segment side lengths. All right. A, B equals, put a line over it. Yes, that'll be X. The next one is BC, also X, good. And then AC,
X squared.
not X squared, you're very close. X radical 2. Yes. Everybody, I know that is a new word. It might feel silly, but I'm going to make you do something. I'm going to have you repeat after me. Okay, everybody say X radical 2. X radical 2. Again, X radical 2. And X radical 2. X radical 2. Okay, new vocab word. We're going to be saying X radical 2. And in the other kind of triangle, it'll be radical 3. That is easy to get mixed up. So that's why we take good notes and have good pictures to look back at. So that if we do forget, well, I don't expect you to remember it. I don't expect you to memorize it. If you do remember it, that's really cool. But good notes are key. Yes.
If the radical is the exact same as the square root, then why are they interchangeable?
They are interchangeable. So I could say x square root of 2, or I could say x radical 2. Those words are completely interchangeable. You can use either one. I think I don't have a great answer for why that is. And now I am very curious, so I might have to look that up on our break. But I think sometimes one or the other just rolls off the tongue more naturally. So let me write that on a sticky note because now you have me curious. Square root versus radical. Because of the x, maybe? Yeah. Ooh, actually, maybe because x square root, like that S sound, is a little awkward to go between. That would make sense. And x radical versus x square root. Interesting, interesting. I'll look that up later. Okay, so we should have a guide made for our side length measures, our picture. We've got everything all nice and pretty. So now let's write kind of a step-by-step guide. And there's really two different scenarios that could happen with a 45, 45, 90 triangle. Scenario number one is that you're given the value of x. Okay, that's where you're either given AB or BC. Because if we're given x, then all we have to do is solve for AC. So let's see. First step, I'm going to say always. I would say, I don't know that I want to write this as a step, but I think it's always a great place to start labeling things. Make sure you know which side goes with what measurement. But after that, the first step that we're going to take is to solve for x. Step one. Now, if we are given AB or BC, step one is already done because those are equal to x. If we are given AC, do we have x already?
No.
No, we don't. So this is how we would have to solve. I'm going to make a note down here. A, B, and B, C equal x. But if we're given AC, what we would have to do here is whatever number they give us for AC, we have to set that equal, bless you, to x radical 2. Let's see. So if they give us that AC is a number, to solve for x, we'll do that number equal x radical 2. And if this is the case where we have to solve for x, what is that one step we would take to get x by itself? Divide. We'll divide by radical 2 on both sides. Give us x. So really, you could also look at this as sort of a formula. You can say that AC divided by radical 2 equals x. Yeah. Okay. So solve for x. That's your first option or first thing to do. Now, if you've been given AC, that longest side, and then you solve for x, you have all your sides. If you are given the shorter sides, basically you're given x, how would we solve for that last side, A to C?
We could just plug in x to radical 2.
Yes, 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 yes. So step 1, solve for x. Step 2, plug in that x value to solve for other sides. When we say plug in, that just means we're replacing x with whatever number x is. So I'm going to write x equal to replace. Okay, so those are your 2 steps for 45, 45, 90. And then I am going to give you a few to try on your own. For practice, let's see, I'm going to give you for the first problem, I'm going to give you that AB is, I'm going to give you a decimal, 6.5 inches. You can solve for the other 2 sides. Second problem, I'll give you two point 3 inches. Okay, so there's 2 practice problems that we are going to solve for all the missing sides using a 45, 45, 90 triangle. Now, what I'm going to do while you guys do this practice is I'll set a little timer and then I'm going to kind of come around, see how we're doing. But feel free to help each other out, work together. If you notice that somebody next to you looks like they're a little stuck, ask them if they want some help. If you are somebody who you understood this in the first 5 minutes of class and you're like, this is boring. Well, it does not have to be boring, because if you got this, then you can take the next level role, which would be kind of my little teacher assistant. Go around with me as I go around and see if your classmates need help. Okay. I think that's a great way to learn yourself, even, is teaching others. So, before I kind of blow this up a little bigger, do any of you need to see anything else above? Do we have it? Okay, so I am going to freeze my screen. We're going to set like a good 10-minute timer, and I'm going to come around and see how we're doing with this. Help each other out.
Oh.
All right, so walked around the room and I saw some good stuff on your papers. For number 1, AB was 6.5 inches. What is BC?
6.5 inches.
Also 6.5 inches. Both of these are the same. What is, let me use a darker color. I feel like you might not be able to see that. What about A to C?
9.19 inches.
9.19 inches. Can anybody explain how they got these values? It is the steps that can get you. Does anybody want to kind of explain the steps? Erica?
6.5 inches times the square root of the radical 2.
Okay, so 6.5 inches times radical 2. And that gave you the 9.19?
Yeah.
Perfect. Okay, so does anybody know why we did 6.5 times radical 2? Why did we do this? I saw lots of you got this answer, so lots of you did this.
To solve for X.
To solve for X? Did we solve for X here as AC X?
Oh, X is already solved.
X is already solved for. 6.5 is X, right?
Yes.
Okay. And we know that by looking at the picture. A to B is 6.5. A to B is X. So A to C, Erica?
A to C for the shape triangle is defined as X times, not radical 2.
Yes, A to C is, as we see in our picture, X times radical 2. And we've also got it listed out here to the side. Sometimes seeing that list is helpful. So A to C is X radical 2. We knew that A to C was X radical 2. We knew that X was 6.5. To find this 9.19, we just did 6.5 for X times that radical 2. We just plugged it in, right? We plugged it in. Okay, awesome. Awesome. Do we have any questions about number 1? Let's look at number 2 then real quick. We don't know A to B. We don't know B to C. We know that A to C is 22.3. Does anybody want to share what they got for A, B, and B, C? Lisa?
I got 15.7.
15.76. You guys get that too? Awesome. Now, is that for both or just one?
Both.
Both. How do you know that?
By X root row 2.
Mm-hmm.
This is
2, and then 22.3 divided by 2.
Okay, so let's see. You have X radical 2, and that's AC. And we also know AC is 22.3. So did you start it kind of like this where you set them equal? Okay, perfect. So if we're solving for X, we have to set up an equation. That's what we did. And then what did you divide by? 2. Not 2.
But
Not 2.
Radical 2.
Radical 2. Yes.
Still bored.
Yes. Divide by radical 2. And we got 15.76. Because those X, the radical 2 cancel. We get X by itself. 22.3 divided by radical 2. 15.76. Good. And A, B, and B, C are both X. So, those are our answers. All right. Well, don't worry, it's break time. Let's take 15 minutes. So that would be what, 41, 10:41-ish. So we'll take a break, come back around 10:41. And I'll see you in a bit. All right, we're back from our break, and I'm gonna start a second page in our notes. So I'm gonna title it Geometry again. Still in Unit 2. And looking ahead, like I said, this is kind of the very last topic we'll talk about, and for Unit 2 anyway. Thought about doing it today, but I'm thinking tomorrow. Tomorrow we'll probably start looking at a practice quiz. Now, doing a practice quiz and a quiz on the same day, that was a lot. So let's not do that tomorrow. I'll let you have the option if you want to take the quiz the same day as the practice quiz. But we need a little break in between. I want to be understanding. So anyway, that's what's to come. Tomorrow we'll probably look at a practice quiz, and it's just going to be over what we've been talking about in Unit 2, triangles. So we'll make sure to do a big review of everything before that. But this is day 9, notes continued. And the other special right triangle would be the 30, 60, 90. And for a 30, 60, 90 triangle, we will not have two sides the same length anymore. Now we have 3 different lengths for our sides. So I am going to start with a line going straight up and down. And I think I'm going to make that line go with, I don't know, like 3.5-ish inches. Three and a half inches. Then let's see what I can do. 4. Okay, this will be perfect. 3.5 inches. My next line, I'm going to make about 2 inches. So our hypotenuse, the big line, the longest one, should be 4 inches. So 3.5, 2, 4. If you're just wanting your notes to match mine. Then we're going to name this triangle with 3 points. The top point will be D. And then straight down from there on our right angle will be E. And the bottom right corner is going to be F. We can look back at the do now for this next part. But let's see. What is the measure of angle D?
30 degrees.
30 degrees. Good. 30 degrees. Okay. What's the measure of angle E? 90 degrees. And we draw a box. And then what's F? 60 degrees. Now, we don't want to put one arc on both angles. One of them should have 2 arcs.
Why?
Good question. Does anybody know why?
60.
Because it's 60?
But boy, you know, more that inspiration.
Yeah, give me a more in-depth explanation. How come I can't put the same number of arcs on these angles?
Because they're different.
Yes, they're not the same size. They're different. these angles are not the same. If you put the same number of arcs, you're telling me the angles are the same. These aren't the same, so don't put the same number of arcs. Good. Okay, so we now want to fill in our x values. Right across from angle D, the smallest angle, is also going to be the smallest side. So right across from 30, what is the length from E to F? X. This is our X. The smallest side is across from the smallest angle. Now, next, let's look at the longest side. That's across from the largest angle, 90. So does anybody know what is the length from B to F? 2x. And that is always 2x. EF is always x. So EF is half the size of DF. And DF is twice the size of EF. Okay. Now, across from the middle size angle, 60 degrees, angle F, now we have the length from B to E. Does anybody want to tell me what that is?
Radical 3.
X radical 3. Good. So not X radical 2 anymore. Now we have X radical 3. So it changes depending on what type of triangle we're using. So we always want to be really careful to make sure we're looking at the correct picture for the correct problem. Okay, so we have those all labeled, and I'm also going to write a little guide out to the side. DE, DF, and DF. So D equals DF equals, and then D. We can write the correct values based off of our picture. So I'm just going to go from top to bottom. D to E is X radical 3. Everybody say that. X radical 3. Again, X radical 3. Now you. X radical 3. Okay, yeah, we're going to remember that. X radical 3 is DE. Next we have E to F. What's that? S. Good. And D to F. What's that? 2x. Good. So now we have 3 different values. It's slightly different. So we do have to be a little more careful when we're solving problems with a 30, 60, 90 triangle. Sometimes this one will take a few more steps, but we can do it. So, same step process. The first thing you always want to do is try to solve for x. Okay, so let me give us, let's see. Like an example problem. Let's say that you are given the measure of DF. And DF, let's say it is 23 inches. EF is 23 inches. My first step here is to solve for X. How would I solve for X if all I know is DF?
But you can do 23 times 21.
23 times 23.
Or 23 times 2.
23 times 2. Let's see. So we're solving for what? What are we trying to find right now? We're solving for X. Okay. So do we know what X is yet? We don't know what X is. What do we know? Erica, what do we know?
We know that, the line D to F is 3 inches. And
Okay.
that line is also 2x.
Okay, so we know that from D to F, it's 23 inches. And we know that from D to F, it's 2x. So if D to F is equal to 2x and D to F is equal to 23, how are 23 and 2x related to each other? They're the same. So they are equal. Good. So what equation can I write?
23 equals 2x.
23 equals 2x. Good. Now, if I'm trying to solve for x, how will I do that? We want to get x by itself.
Divide by 2.
Divide by 2. Good. On both sides. Those 2's will cancel and we will have x all by itself equals 23 divided by 2. 11.5, good. Okay, so we solved for x. What does this help us with?
Yes.
It helps us with EF. EF is x. So let's write that, x. So if EF is x, and we know that x is 11.5, what's the measure of EF? 19 is going to be the number we just found. EF is x, and x is 11.5. See that? So EF is 11.5. Misty, where'd you get your 19?
Oh, I was doing the I'm sorry.
Was it a different problem?
Yeah.
Okay, I got you. That's okay. As long as it makes sense to you, that's good. Okay, does everybody see where we got EF?
No.
So now that I have EF, I just need to find DE. I don't know the number value for DE. What do I know for DE? Erica.
DE is equal to x radical 3.
Yes, DE is equal, according to our drawing, to x radical 3. So I'm going to write that over to the side, x radical 3. I know x, and I know that DE is x times radical 3. How can I solve for DE?
11.5 into x.
Yes, yes. We're going to take our x value, 11.5. We're going to plug it in for x. So instead of x times radical 3, we're replacing x with 11.5 times radical 3. So we should just be typing in 11.5. Again, square root radical 3 this time, not 2. And you should get 19.92 if we round it up. 19 point, I would take 91, that would be fine. 19.91 or 92. Now, did everybody get that? Does anybody feel unsure about how we got that? Or do we feel good?
Yeah.
We feel good?
Yes, we did, but yeah.
Okay, so number 1 is done. Did it. We did it. There's only one version of this problem that might be slightly trickier, and that's where we're given DE first. I gave you the medium problem first. The easy one would be if we were given X already. But now let's do one last one together. Okay, so DE this time, I'm going to give you the measure of DE, and DE is going to be 13 inches. You did it right. Step 2 here. Sorry, guys. It's the same step 2 as the other one. Bless you. You're just plugging in the X value to solve for other sides. See if you guys can get this one. Give you a few minutes to try to figure it out on your own, and then we'll talk about it. So go ahead and try to get a start on number 2 here. Try and get started. We'll go from there. We'll see how we do. You're staring at your paper and you're very lost, not sure where to start. Stick finger up in the air, I'll come to you.
Okay, so this is 13, you plug that into there, right? So let's see, where is that after, right, plugged in?
So you would plug in, certainly once you know X. So the first thing you want to see is this first step. Do I know what X is? Now,
All right.
And then you can do it from there. So let's see. So X times radical 3 equals 13, right?
Okay.
Because that's what we said. 13. It's 13. So we have, go ahead and write that first. We're going to start with an equation.
What am I writing?
So you were trying to say that X is 13.
I was
But we don't know that yet. We know that X equals 3 is 30. It'll take me about making sure because D is X Yes. You're going to solve. Are you sure you want, are you gonna settle it? Yes. So,
Yeah, I was like, I'm gonna keep that one.
No, somebody can buy it. Somebody can buy it.
good. That'll give you your X.
That's gonna be hard.
Yeah.
So I'm gonna imagine how-
And then you can plug in the solver for the last one. You got it, you got it. Don't know the answer yet, but I can at least tell you what the process is like. Alright. No, correct. Just one. I'll wait you.
Cause you gotta cut all that out, cause this is like.
I said you work on guard before and then 4 or 5 minutes. Yeah.
Yeah, this is a job.
Yeah, no, for real.
Beautiful. Perfect. And you did that times 2. So, awesome. That's
What I
great.
feel is that music.
Okay, did anybody else feel lost?
Yeah, for me, but. Actually, I'm talking about right now, it's like that shit.
How you feeling around that one?
I seen that they had.
I think and then it's not, you're not like looking back up and down. So, yeah, there you go.
You gonna go to that, or you just go ask, but I don't know, that's what they want, So like, you ask what type of party, like, sometimes. Yeah, you're not supposed to. They'll order.
Okay, alright, then.
He hit up to that card and he said it like, oh my God, he
Yeah,
gonna.
he gonna be happy.
Yes, that was the step.
I was when I seen that.
Bye. There it is. That's the right number. Good. So instead of 2,
It's like.
Yes.
And you gotta do that, you
Yes, so now that you know what X is,
And you said all that, Hobby Lobby.
That's where the store.
yeah, it's all for X.
Small party,
Now you want to find.
take notes of your story.
You already know what X is.
It's hard though, it's hard.
Yeah.
Like. That 5 hours, usually that. Weeks process.
So that's your X
Oh
number.
my God. Yes, it's hard to.
So. So my eggs, I do 2 eggs.
No way, it was $20.
Five.
I still ain't got that come out the whole.
I'm confused, but I'm just. I think it's because it's the eggs. Oh,
It
that's
is.
the shit.
Yes,
Well, we
so
are working on this
it's
side.
D to F,
Great.
D to F, what we're trying to find now. I know what X is.
So the videos next week.
5.
Great.
So
They got
D
they
to F is 2 times
they
X.
feel pain.
Then we just take whatever X is times 2.
Yes,
Yeah.
I see you videos.
So how are you
All of
finding
it.
it?
Oh my God. I said, you should never be made grocery parks like.
Here.
Oh, it's just regular.
That's regular now, yes, ma'am. Yes. That's your answer, girl. Nice.
It took me out.
Yes. Yes. Okay.
I wanted to show you the paper.
That
what I had.
Let's look. Did I even pause this? Nope. Well, I guess it kept going. Number 2. What'd you guys get for EF? 3.75. Anybody get something different?
I got 4.33.
4.33. Anyone get something different?
7.5.
7.50. Okay, we got 3 different answers. So there must be 3 different ways that we went about doing this. Let's see. Who feels brave enough to share how they got their answer? I'm not going to tell you which one's right yet. Erica?
So we have 13 inches for D,
Uh-huh.
and we know that D is x radical 3.
Okay,
So
so
to find x, which is EF, you just plug 13 in where x is
we're going to plug 13 in for X.
and divide.
Okay, I see. So let me label off to the side here. I know DE is X radical 3, and EF is X. So what you're saying is we know that X radical 3 is 13, and you're going to solve for X with that equation. Okay, perfect. So let's do that. I'm going to set up this problem. Go ahead, Erica.
If you solve for x, don't that eliminate 2 other sides?
On a 45, 45, 90 triangle, yes.
Yeah.
But remember, this one's got 3 different sides.
I know a lot of that's just to remind.
Yes. Okay, so we know that DE is 13. We also know that DE is X radical 3 because it is the definition of this triangle. So what we're doing here is solving for X like it says in step 1. I know that X radical 3 must be equal to 13 because they are both equal to DE. Does anyone have issue with that? Okay. So then what did you do here, Erica, to solve for X?
In my notes, for just so I know, what I did is I wrote a division sign between x and radical 3.
Okay.
For me, that makes it easier.
So you're basically dividing by radical 3 here.
Yeah.
Dividing radical 3 here. Okay, and then those would cancel, which does give us the x by itself. Equals. And so now we need to type in our calculators. Here's where I see a lot of mistakes. I see people just type 13 radical 3. That's not what this says. It says 13 divided by radical 3. So let's all type that in and see what number we get. 13 divided by second radical 3. Enter. Oh, so I got the 7.50, or you could round up to 7.51. I would take either answer, but it looks like that is our answer here. Okay, so X 7.51. If you put 50, that's also fine. Now, if you got the 3.75 or the 4.33,
I just divided 13 by 3.
oh, you did by 3. That makes sense. So 13 divided by 3 would be a little different. That would give us the 4.3. Okay, that makes sense.
Good radical.
Gotcha. So don't forget the radical. Does anybody, I forget who all said they got what. Do you remember how you got the 2.75?
I switched it.
You switched it?
Yeah.
So
I accidentally put 750 on BF instead.
oh, and that, okay. So you did technically get the right number, just in the wrong spot. Okay. Okay, makes sense. Perfect. So EF is X, and X is 7.51. So 7.51 inches is our answer for EF. Now, DF. How do I find that?
2x equals 7.51.
Okay, so 2x equals 7.51. Let's see. So if x equals 7.51, can 2 times x also be 7?
Or is it 2 times 7.51?
That's it. 2 times x. 2 times 7.51. So this is another part that I think is a little tricky. Once we solve for x, remember, we know what x is now. We do not need to solve for anything else. We're just plugging that in at that point. Once you solve for x, you're just plugging in. So EF is 2x, which means 2 times whatever x is. So instead of 2x, I'm going to write 2 times what?
7.5.
2 times that 7.51. And that's going to equal what? About 14 point what? 0.51. Let's see.
I got 15.02.
15.02. I'm going to type this and see what we get. 2 times 7.51, and I got 15.02. Did you type a smaller number on there? Okay, I gotcha. It sounds like it was pretty close though. So DF, if you used 0.50, you would have gotten just regular 15 without a decimal, and that would be just fine too. I won't count that wrong. That is also correct. So I'm going to write 15.02 inches for DF. Okay. I know these are a long process. Yes.
Probably just something rounding up for EF. I got 15.01.
Yes, that would be just fine. 15.011. I would take it. Absolutely.
But why did you round 1 up to 0.2?
I didn't round it up. 7.51. Oops, I'll show you. You might have had a different number here.
For EF, I've got 7.505.
That's what it was. You included 3 decimals, and so your answer is technically more accurate. Since we rounded at the first step, we already got the 0.02. So there is going to be some variation depending on what step you simplify at. If you never simplify, you will have the most accurate answer. Or not simplify, round. If you never round, you will have the most accurate answer. But I got 15.02. You might have gotten 15. You might have got 15.01. You might have even gotten like 14.9. Those would all be fine. Okay. Any final thoughts? Yes.
I don't think the answer should ever come out to 14 or under.
It might not. It might not. Just, I guess. I don't know. You're probably right. I'd have to work out more possibilities to know for sure, but you might be right. Okay. Again, any final thoughts, questions, comments, concerns? It's a good day. Good. I just missed you guys.
You should have sent it to me.
Yeah, okay. Thought we were having a moment. All right, so I'm gonna say, because we're probably planning on doing a practice quiz tomorrow and a quiz coming up here really soon. We are gonna do some more review here, not today. I would like to let you guys out today. So what I would like you to do is show me the notes that you took today, and that will be your exit ticket. Show me the notes you took. Show me that you took good notes. All right, that will be your exit ticket. If you did not take good notes today, then that's your homework, is to go watch the video again and take notes, and then I'll give you your credit.
What the exit ticket from yesterday?
The exit ticket from yesterday, that was in the video. I did not give you instructions to have to do it, but if you did do it, then that might possibly be some extra credit. So turn that in if you do it. The exit ticket from yesterday could be some extra credit. Just saying. But I'm not gonna advertise it. It's just if you happen to do it, great. But that's all. Your exit ticket today is to show me your notes, and then I will give you a check mark on it. That's it.